Good morning, everybody. Thank you for coming to the Data Colada Seminar Series. It's my pleasure today to have Katherine Coffman speaking to us, and she will be here speaking and joined with her panelists, Linda Babcock, Manuela Collis, PJ Healy, Alex Emas, and Becky Schomburg. In addition, Yuri Simonson and Joe Simmons will be here as well. With that, I will turn the floor over to Katie, and looking forward to her talk. Thank you so much, Katie.
Yeah, it's my pleasure to be here. Thanks so much for having me. So I'm going to start sharing my screen here. All right, fantastic. I think I got everything situated. So it's my pleasure to be here and talking to you about this work on stereotypes that's joint with Manuela, who has the pleasure of being with us here today, and she'll be starting her PhD at Rotman in the fall. So excited about that too. So this is a project that tries to think about how the beliefs we have about our own abilities are formed and how they persist over time. So we have a variety of evidence across different fields and different settings that our beliefs about our abilities and our talents are sort of pivotal for a lot of the important decisions we make. Whether we think about decisions like willingness to compete or how we might behave on a standardized test, to thinking more broadly about the choices we make in our career, like when to put ourselves forward for promotion, how good we think we are is a really big input into many of those decisions. So there's lots of existing evidence for gender gaps in beliefs of ownability. And I'll say most of those studies that find men more self-confident than women come from male-type domains. And what do I mean by male-type domains? Because that's going to be pretty central to what we talk about today. Here's an example from an older paper of mine, thinking about what the gender gap in self-confidence looks like across different areas. So this is the gender gap conditional on ability in sort of believed ability, right? So think of this as the gender gap in self-confidence in favor of men. So what I'm showing you here is across 4 different sort of more academically minded and pop culture minded areas, right? Environmental science, history, geography, and sports and games, sort of the standard finding of men more self-confident than women. Okay, but what we can see is that if we shift our attention to areas that are actually more usually associated with female talent, right, stereotypically female type domains, we can actually reverse this gender gap in self-confidence. So when we start thinking about arts and literature, or even just pop culture generally, then women tend to be more self-confident on average than men. Okay. So most of our evidence thinking about gender gaps in self-confidence, think about static contexts, right, where we might have you perform in a given area, and we ask you, how do you think you did? Or we say, how do you think you're going to do in this upcoming area? But an important open question here is, why do these gender gaps sort of persist, right? If we sort of measure your beliefs about your ability in a certain domain, right, well, we might see that in a point in time that the woman is less self-confident than man, but we would think sort of as she goes through life and accrues more information about herself and more familiarity with a range of domains, that those gaps should start to close. Right? And from a policymaker perspective, we'd like to understand how we actually close them effectively, right? What can we do to sort of correct sort of miscalibrated beliefs? Right, so I think the example I want you to have in the back of your head here is if we're thinking about sort of a talented but underconfident woman, right, in something like STEM, is the intervention of just giving her more information going to be sufficient to make a significant impact on her beliefs? Right? And understanding the answer to this question is really a question of, okay, how do people update their beliefs about themselves in response to new information? And that's going to let us say something about how these things persist, why they persist, and what types of interventions are most likely to be effective. So this question of how individuals update their beliefs about themselves is one that's been studied particularly recently within economics, right? So thinking about this question of, okay, I get some signal of how, my IQ skills compare to others, and then I get new signals over time. How do my beliefs sort of evolve in terms of how I think the likelihood is of me being in the top half of performers, right? So there's a range of studies in these areas, and I would say the 2 most classic findings is that people tend to be more conservative than predicted by the Bayesian model, so some stickiness of beliefs to priors, and some evidence of asymmetry effects. right? Where we're much more likely to update our beliefs in response to good news than in response to bad news. And you could tell a story in line with sort of motivated reasoning or image concerns that would lead to that type of motivated asymmetric updating. Now, despite this variety of papers, we have sort of more limited evidence on gender differences. There are a couple of papers in this area that explicitly consider gender. A couple of them find evidence for greater female conservatism than male conservatism. So more stickiness for priors for women than for men. The results on asymmetry are a little bit less clear. What we're going to try and do in this paper is sort of dig into these gender differences more deeply, right? So in particular, we're going to think about this question of how individuals update their beliefs about themselves. And we're going to try and unpack the gender differences we see. So in particular, when we think about how men and women may differ and how they update their beliefs, we're going to try and ask, okay, well, is this a difference between sort of men and women, right? Or is it really more about how gender congruent that area is? So if you think about that example I gave you before, where we saw different patterns in sort of the more male-typed versus the more female-typed areas, we're going to ask a similar question here. So let me sort of illustrate what I have in mind. So imagine you took a man and a woman with the exact same ability and the same belief about how they performed, right? That same prior belief, and you consider two different fields, right? One sort of stereotypically male type field like business knowledge, and one more stereotypically female type field like verbal skills, right? So they start with the same prior belief of their abilities, right? And then we're gonna provide them with the same good news. So suddenly unexpected good news arrives. We say, hey, turns out there's a good chance you're actually a 10, right? You thought you were a 7, turns out you're probably a 10. The question we're going to ask in this paper is, how do they update their beliefs in response to that information? And in particular, we're going to try and distinguish between maybe two sort of relevant hypotheses, right? One is sort of the gender hypothesis, which a few of these past studies have touched on, right? This idea that sort of men are going to update more than women, right? Men are going to be less conservative than women, and that would be true sort of independent of field. Right? So whether that information arrives in business or it arrives in verbal skills, men are going to be more likely to update their beliefs to thinking they're a 10, whereas the women are going to be more likely to stick with their prior. Right? We're going to test for that explanation versus a different explanation that's more about gender stereotypes, right? And there the idea is, well, it depends sort of what type of domain you're operating in. When you're operating in that male type domain of women, of business, you might expect men updating more than women, versus if you're operating in that verbal skills domain, you might expect that pattern to flip. And actually this slide, while not based on real data, is a great illustration of the type of finding that's going to fall out of our study, right? Where the extent to which someone is willing to sort of believe good news about themselves and update their beliefs is going to be a function of how gender congruent that area is, right? How consistent is the news with their pre-existing stereotype? Right, so what we're going to find, and I'll show you across two studies, that the gender stereotypes play a big role in how individuals respond to information. Right, so you can think of past work as showing quite clearly that stereotypes shape prior beliefs. Right, absent information, stereotypes shape how good we think we are in different areas, even conditional on ability. Here we're going to go a step further and say stereotypes don't just shape those priors; they actually shape how we process new information. And that's going to be a big part of sort of why these gender gaps can be persistent over time. Right? We'll show that both men and women respond more to information, particularly good news, when it comes in a gender congruent domain than in a gender incongruent domain. Okay, and I'll show you too, I think if we have time, that these effects are primarily sort of beyond what would be predicted by the Bayesian model, right? That there's sort of some unexpected updating behavior.
Hey, Katie, there's a question from the field. I think you might cover this later, but how do you determine what's a female types category and a male types category?
Great, yeah, so I'll show you some data on exactly that. I think there's a variety of ways to do it, and we'll do it in two ways in this paper. So one is to ask people sort of their qualitative impressions of different areas. So we actually ask the participants that we survey to evaluate whether they think a given variety of fields is sort of more male typed or more female typed. And the way we phrase that question is, do you think this is something that in general men are better at or women are better at? And they sort of drag a slider scale to indicate their beliefs. You could also proxy for the gender type of the category by the average gender difference in performance, right? So one of them is sort of the belief about that gender gap. One of them is the true gender gap. In the study I'm going to present today, those two things are highly correlated, so you actually get the same answer independent of which one you use. But I think all of those things, you could also think about sort of representation of men or women within a field as a proxy for the type as well. So I think there are a lot of ways to sort of get at this, and I'll show you a couple of them. All right, so what's the plan for today? I'm going to try and maybe somewhat aggressively talk about two studies. So I want you to think about the first study as really being an extended motivating example, right? So it's going to be a really simple example or a simple experiment that's focused on arguably a really important domain, right? Thinking about cognitive ability and our beliefs of our cognitive ability, right? There are going to be a lot of unanswered questions there. And in particular, since we're focused on a single domain in study one, we're not going to be able to say much about whether this is sort of a gender difference versus a sort of effective stereotypes that's going to vary by the domain. And that's why we're going to conduct study two, which is going to be much richer, and it's going to allow us to unpack some of these different factors that might be at work. Okay, so study one. I'm going to dive right into the design. Again, very simple experiment. It's run with a large sample online, which I'll talk a little bit more about. It takes them really a very short period of time to do this whole study. So they're going to start by taking a test of their cognitive ability, which is drawn from the Armed Services Vocational Aptitude Battery. Right, so we're going to skew the questions from the ASVAB to be sort of primarily what we think of as more male-typed. So drawing from science and math, assembling objects, and we're going to give them 5 minutes to answer as many questions as they can. Right, so there are 30 questions. They're not going to get to all of them. They see them all on one page, and they can sort of answer as many as they can get to in the time they have. We're going to think of their score as just being the total number of correct answers that they submit. Okay. Immediately following the test, we're going to ask them to guess what score they received. Right, so this is a belief of an absolute score. I'm going to call this their prior. Right, so it happens after they take the test, but before they get any information. And we're going to incentivize this by paying a bonus payment if they guess their true score exactly. Okay, so if you're thinking about sort of what we're eliciting here, imagine participants sort of have a whole distribution, right, a likelihood of having any particular score. By giving them a bonus if they guess exactly correctly, we're eliciting sort of the mode of that belief distribution.
Katie, I just want to ask, I guess, a clarifying question. So you're calling this a prior belief, though it's elicited at a time where they've already seen and taken the test, right? So, for example, men and women might already believe that they're having different scores on this test because they've seen it and taken it, right?
Yeah, for sure. So yeah, I'm using that prior in sort of quotation marks, right? So yes, so the prior, it happens before they get information in the form of sort of the structured signal I'm going to give them, which I control quite cleanly, but after, of course, they've gathered information from the test. So surely it's possible that you could actually go back and elicit beliefs before they take the test and think about how things track, even just like before the test, and then after the test, after the information, and track that. I think that would be really interesting. What's sort of nice about this prior and the posterior I'm going to consider is I'm going to sort of isolate their information set except for the information I'm going to provide them. And I'm going to be able to like sort of consider people who I know sort of saw the same information within the same context and didn't necessarily read a different set of questions or something like that on the test itself. But yeah, you could consider performance, beliefs before performance too.
Perfect, thanks.
Great. Okay, so after they give us their belief of their absolute score, we're gonna give them this information. So I wanna think about this information as being quite informative, right? So it's going to be pretty accurate. It's going to arrive immediately before they provide their beliefs. It's going to be exactly on the object of interest, which is their performance in the test, and it's going to be tailored to them individually. So in that sense, the signal we're providing, this information, is in a lot of ways a pretty good scenario relative to the types of information you might receive outside of a laboratory or controlled experiment context, where it might be much more subjective, unclear how to interpret it, right? It might arrive at various points in time, right? This is really sort of well tailored to this context and the question they're going to be asked about. Okay, of course, it wouldn't be an interesting experiment to just tell them exactly how they did and ask if they can report that back to us. So we want to have some noise in the signal they receive. So the noise is going to take the following structure. Right? With probability Q, participants are going to see a signal that is equal to their true score. And with probability 1 minus q, we're going to take that true score and perturb it by a noise term. And that noise term is going to be drawn between -5 and 5, right? So q is going to vary by treatment. We're going to have a 60% accuracy treatment, right, where they see their true score 60% of the time, and a 90% treatment where they see their true score 90% of the time. And that's going to allow us to say something about whether increasing the accuracy of the information is any more or less effective in sort of closing these gender gaps. Okay, so the Q's and P's that I show you here are not how we explain it to participants. They see it in a more intuitive way, and they have to answer some brief understanding questions before they actually proceed to receiving the information. Okay, so following the signal, we simply re-ask the belief question, right? Guess your absolute score again. We're going to call this their posterior because it happens after information. And again, they're going to get a bonus payment potentially if they guess their true score correctly. Okay, so that's the whole thing. Pretty simple, right? At the end of the experiment, we get some basic demographic information from them. We run this with roughly 1,000 participants. It's actually embedded in a larger study. So it's a study on when to apply for promotion. This occurs as the very first part of that study, and we're kind of drawing it out. Again, study 2 is going to be sort of a deeper dive into this. It's going to be tailored exactly to the questions we're interested in. Great, so I'll just show you that men and women look roughly similar on a lot of the demographics we measure. In particular, these are mostly people who went to high school in the US. They have similar degrees of educational attainment, which are pretty, diverse over the levels of attainment. Average scores here are around 10. Importantly, men do outperform women in this context on average. Men are answering about 11 questions correctly. Women are answering closer to 9.5. Okay. With that level of mean performance too, I want you to think about, remember that signal, that noise draw is subtracting or adding up to 5 points, right? So you can have pretty good movement around that mean. It also means most of our participants are seeing a signal that's actually feasible, but we don't constrain that. So it's possible you could see a negative signal or a signal higher than 30. It just happens very, very rarely. In the data I'm going to show you, we just consider all of those people and don't worry about it. The results look the same if you throw out the people who saw harder to interpret signals. Okay, so what do the results look like? Well, we start by replicating a lot of past findings that if we think about their prior beliefs, we see that women state prior beliefs approximately 0.6 points lower than men. Again, this is conditional on how they actually perform. So if you want to think about the magnitude of that effect, it's about 1/1300ths of a standard deviation. Okay, so importantly, our question is to be, okay, so how effective is information in actually closing that gap, right? If we provide everyone with highly accurate signals of how they actually did, can we make a dent in that gender gap? And the answer is not really, right? So their posterior beliefs, the gender gap is still around 0.5 points, 1/1200ths of a standard deviation of ability, right? So we've essentially made no difference, right? You might say, okay, well, maybe you're much better off in that 90% treatment than the 60% treatment. If anything, the remaining gender gap is directionally larger in the 90% treatment and than the 60% treatment. So more accurate signals are no more effective in closing the gender gap. So I want to show you visually sort of what's going on. All right, so let's see. I think you can now see my mouse as well, yes? Okay, great. So the way this graph is organized is we want to control for your score. And I have PJ on my panel here, so PJ can chime in and say, right, that your ability or how difficult the task is going to be a big predictor of the level of over or under confidence you display, right? So it's going to be important to sort of account for people's ability in this task. So their score is on this x-axis, and on the y-axis, I'm just graphing their overconfidence in absolute beliefs, right? So how they thought they did minus how they actually did. So the first thing to just notice is that almost all of these, right, these are linear fits of the data, lie below 0. So this is a context where people are underconfident on average, right? Our focus is going to be in thinking about sort of the distance between these blue and red lines, right? So for a given score, the vertical distance between the two lines is going to tell us the size of the gender gap in self-confidence. So the dashed lines are prior beliefs, right? So you see that sort of 0.6 point effect that's estimated to be quite constant over the ability distribution. Well, what does the information do? right? The information essentially kinks everyone up closer to the truth, right? So you've got a big reduction in sort of the average degree of underconfidence, but you're really not having much of an impact on the estimated gender gap, right? So big move towards accuracy, but no real shrinking of the gender gap in beliefs. So I think what you can see from that figure too, but what's worth pointing out is that one reason why information could fail to close a gender gap is that the information just doesn't cause people to change their beliefs. That's not what's going on. The information is really effective at changing participants' beliefs on average, right? So the absolute error in beliefs on average falls from about 3 points to more like 1.5 points. This error reduction is larger in the more accurate signal treatment, suggesting that signals intuitively are working largely the way we'd expect. They're just not moving the gender gap very much, right? As a result, if you think about sort of the gender gap as a share of like the average mistake in beliefs, right? How much of being wrong about your belief is driven by sort of this gender gap or is connected to the gender gap? Well, the gender gap is about 18% of the average error in beliefs in priors, but 1/3 of the average error in beliefs in posteriors. So a lot of the sort of mistakes that are left over by the time we've provided information seem to be connected to the gender gap. Okay. So I think, study 1 provides some nice illustrative evidence, particularly from a context we think we might care about from an educational and career relevance perspective, but it leaves some questions unanswered. And in particular, right, because I only have sort of point estimates of beliefs, a big question we can't get at with study 1 is how much of this behavior is Bayesian, right? So under a Bayesian model, people who start with different priors and see the same information are going to end up with different posteriors, right? So is all of the action here fully predicted by a Bayesian model? And actually, we shouldn't be surprised that information is ineffective at closing gender gaps. Okay. So in study 2, we're going to try and develop actually a Bayesian framework and collect enough information that we can understand departures from the Bayesian model of our participants. The second part, which is really what I previewed at the beginning, is that we were focusing, like a lot of past studies, on sort of a single field, right? Just this domain of cognitive ability and comparing men and women within that field, right? Would it be the case that these are the types of patterns we get across a range of domains? Or are we going to see that the gender gap and the gender differences in updating behavior will vary with the gender type of the domain? Great. So I'm going to shift gears to study 2, but I want to pause in case it's a good time for questions.
Katie, one question that's been coming up in the audience and the question I have in my mind as well is the way the signal structure works is it's the true score plus or minus 5, right? But what if the true score is close to the max or close to the min, then you can get signals that are not feasible, right? Or not representative of a real score.
Yeah, so in practice, it just doesn't happen very often because the average score is about 10. So there just aren't that many people who both have scores close to a boundary and get a big error draw. But it does happen. We allow it to happen. So in theory, you could see a signal of -3. We just throw all those people in our data. We're treating everyone the same. It's just such a small portion of the population that even if we threw them out, the results would not look any different. That's not driving sort of the patterns we see.
Thanks.
Great. Okay.
Sorry, a quick question.
Yeah.
Are you doing anything with the variation in the signal that they got? Because you're just analyzing the conditions, right? Not the actual signal.
Yeah, that's a great question, right? So, and we'll have more data in study 2, so it'll become more feasible to do things like this, right? I think I am interpreting your question as sort of, okay, let's think about someone who got a noise draw of +1 versus a noise draw of +5, right? Those are two sort of very different information shocks in terms of the signal you see. I think the data works a lot like you'd expect intuitively, which is if you want to think about how do I effectively convince you that you did better than you thought, the most effective signal to send them is one that's like +1 or +2, right? That's like positive news, but plausible to a lot of participants, versus once you get to the +5, actually there's more chance that they sort of discount that as being sort of, oh, well, that must have been the noise draw because it's so much better than I thought. Now, that's a very sort of intuitive interpretation of the data. All I could say is the data seems consistent with that type of thinking going on among participants, but of course we don't ask them, do you think it was the noise draw? Do you think it was the truth? We can just sort of see in the data that it seems consistent with that type of thinking. All right, so the design for study 2 is going to be really similar to study 1, but we're going to expand it in a couple of important ways. So the first thing we're going to do, and sort of the most central thing, is rather than consider a single domain, we're going to try and consider a range of domains. And the goal here is not to select the 8 domains that we think are most relevant to predicting your career success. You could probably come up with better ones than these, right? But instead to choose domains that vary most strongly in their associated gender type, right? So we want to have a big range of these things, from things that are sort of considered strongly female typed to things that are considered strongly male typed by the participants in our study. And I'll show you that we achieve that quite successfully with the categories we use. The second important extension is that we're going to collect much more detailed information on beliefs from our participants, right? So in the first study, all we were doing was asking them for their guess of their absolute score. This time, so that we can test the Bayesian model, we're actually going to try and elicit their whole belief distribution, right? What's the likelihood of each particular score for this given domain? So participants enter the experiment, and they're going to complete essentially 3 rounds that look just like study 1, but each time with a new randomly drawn domain. Okay, so within each round, participants take a test of ability. We're going to shorten the test a little bit. Now it's going to be 20 multiple choice questions instead of 30, and we're only going to give them 3 minutes instead of the 5. Okay, the time test also plays a nice role in that it's kind of reducing the incentive to cheat or look up answers. I can show you by their performance that it doesn't seem to be the case that people are really cheating and knocking it out of the park. We think for the most part they're on the page. We also verify this by popping up attention check questions that appear on the page at random points in time, and they have sort of a certain amount of time, like 5 or 6 seconds, to actually successfully click on the picture of blueberries, right, to verify that they're paying attention. Okay, so after the test, and again, I'm going to call this the prior, but it occurs after the test, just before information, we're going to sort of build this belief elicitation, right? So the first page of the belief elicitation looks just like study 1, right? Provide a guess of your absolute score. We're going to pay you if you guess exactly correctly. And now we want to sort of tiptoe towards things that are probably a little bit less intuitive for participants, but are helpful for us in terms of making predictions, right? So on the second page, you say, okay, you just told us you thought you had a score of 10. What do you think the chances are that you had exactly a score of 10, right? What's the likelihood of having exactly that score? So think about that as eliciting the probability mass they put on the mode of their distribution, right? So we could have a lot of variation there. Someone could be really sure that's their score. Someone could be not so sure that's their score. And that's what we're picking up on in question 2. And we think hopefully in a way that's sort of intuitive and not as overwhelming as immediately going to a whole belief distribution. All right, but of course we are going to overwhelm them, right? So we get to the third part, we say, okay, so there are 20 questions. That means there are 21 possible scores. We show them all 21 possible scores, and we say, for each score, tell us what you think the chances are of you earning that score. And we require them to enter a number in each box, and we suggest, but don't impose, when they say, hey, you just told us you thought there was a 60% chance you have a score of 10. Why don't you start by filling that in, right? And so we encourage consistency between question 2 and question 3, but we don't require it. The only thing we require in question 3 is that they actually give answers that sum to 100. Okay.
Katie,
so, yeah.
Sorry, just really quick. How do you think about the points 2 and 3 in the context of like Ben and Anke's and Thomas Graeber's cognitive uncertainty sort of results? So could basically a smaller belief that this is actually, that there's a lot of point mass on this, could that also correspond to kind of uncertainty about how to even think about beliefs and in this context, or how to think about probability distributions? And would that make a difference?
No, it's an interesting question, right? Which is, and I'm sure Ben and Toto's run into this problem too, right? Which is, you could indicate a high or low percentage of having a specific score with then another degree of confidence that, oh no, I'm really sure that there's only a 15% chance I had a score of 10. Mm-hmm. So it's a little bit less straightforward, I think, to completely unpack whether this is the right measure of how uncertain they are, or how sort of, you know, cognitively unsure they are about the answer they've given. You know, and I'll show you some of the specifications that use this data. I haven't thought about interpreting it in line with sort of a cognitive uncertainty story, but it's a really interesting idea. What I will say, and we'll show you this too, right? You could have different ideas. We're going to focus on sort of gender type of the domain, right? Does your level of cognitive uncertainty vary with the gender type of the domain? What we see in the data is, at least for question 2, they do tend to put a little bit more mass on the mode for more gender congruent areas. So they seem to be, if we're willing to call that cognitive uncertainty, they seem to be less unsure about the gender congruent things than the gender incongruent things. But not all of our data is consistent with exactly that type of interpretation.
Okay, so that would actually be really interesting. That would in some ways speak against cognitive uncertainty, because I was thinking of cognitive uncertainty as, you know, being able to think about probability distributions in general. And if you're getting a comparative static in this direction of gender, then that would suggest it's probably not cognitive uncertainty. But
for sure, it could be both things, right? There could be sort of like a level effect of cognitive uncertainty and this gender type domain, you know, right? It's not well designed to tease apart the two, but be interesting. Toto's joining our group, so definitely a chance to have more conversations about what this might be capturing in those lens. Great.
Excellent.
Okay, so in this study, we're also going to ask them to make a guess about their relative ability. So we asked them to think about 100 other participants who are also taking this test. Guess how you rank relative to those 100. Okay, so they're only going to get information about absolute ability, but what this relative ability question allows us to do is to track a little bit whether there are any spillovers, right? Can we change beliefs about relative ability by changing beliefs about absolute ability?
Katie,
Yeah.
Can you game the system? So there's a question from the audience about, could you guess 0? Could you make your answer so that you get 0 so that you get the incentive for guessing right? So
yeah, it's a good question. So for most of these, the marginal incentive of answering an additional question correctly on the test is going to make that not a good strategy, assuming you think you have really any chance of answering correctly. So we are paying them incentives for answering more questions correctly on the test. We're also, and Manuela might remember exactly how we do this. I know in at least some of them, we're basically choosing one question at random to pay them for. So even though there are sort of large incentives on the beliefs questions, right, the chances that you're going to get paid for exactly guessing 0 on that are quite low relative to those incentives for sort of doing well on the test itself. I also think most participants aren't that sophisticated, but over 3 rounds, right, maybe you could learn that strategy. We don't see a lot of that going on in the data, at least empirically. Okay. All right, so signal structure looks very similar to study 1. You'll notice here what we've done is actually dampen signal accuracy. So now our 2 treatments are going to be 50% and 70%. The reason for doing that is a little bit of a mechanical one. So by dampening signal accuracy, we're going to be able to see more people who get noise draws. And that's going to be helpful for answering sort of the question that came up before about sort of 1 versus 5. It's also going to be helpful in sort of distinguishing between people who get good news, bad news, and accurate news, right? We're basically assuring that we have more people in each of those cells. Okay, great. And then finally, after they see the information, we just re-ask all the beliefs questions, again in those same 3 stages. So end of the experiment, we have that same demographic information I mentioned to you from study 1. I'll say now, we also, because we don't have a measure of cognitive ability within the test itself, right, where now our domains are something different, we ask unincentivized ASVAB questions at the end to allow ourselves to have at least a proxy for some of these mathematical skills that we can control for in our regression specifications. The last thing they do in the whole study is they do a slider scale ranking of each of the 8 categories. So this is the question that came up before of how do we measure gender type, right? One way of doing it is just to ask people directly what they think, right? So for each of the 8 categories, they slide a slider scale from, 1 point towards men, 1 point towards women. It's qualitative, so I shouldn't call that a point, right? But they sort of drag it between -1 and 1 to indicate whether they think men or women on average know more about an area.
Hey, Katie, can I ask a follow-up question about that?
Yeah, great.
In terms of the rating, whether the task is more congruent with women or more congruent with men, do you see, or would you predict any sort of motivation among participants after they have a sense of their performance, whether to think of that task as more male stereotyped or female stereotyped? And I guess my question would come that if I'm a woman and I did a task and I was like, oh, I thought it was female stereotype, but I did pretty poorly. Does it protect my self-esteem to rate it as more masculine, and vice versa with men?
Yeah, it's a great question. So actually, I haven't checked it in the data you're going to see today. I've used this question in other studies, including in the experiment that I showed you a slide from up front with sort of the different gender type of the categories. And I was worried about exactly the story you have in mind. It turns out to be the case, at least in this other study, that your own performance in a given domain is not at all predictive of your gender type rating. Which was kind of surprising to me too. I could imagine like, okay, well, if I'm not good at this, it must mean other women aren't not good at this, but we just don't see that. And, you know, one of the things that's really striking, and it's in the 6 categories of that study I showed you up front, 2/3 of participants give exactly the same rankings of the categories, right? So at least from an ordinal perspective, there's just a huge amount of agreement about what these gender types are. And yes, maybe the specific numbers are moving around a little bit. You see the one thing that does jump out is sort of men always think things are slightly more male typed than the women do, vice versa. There's no way to frame that as one versus the other. So there is a sort of like self-serving bias towards your own gender. But men and women broadly agree on what the ordinal ranking is, and even the cardinal numbers are quite similar across large populations. Yeah. We're actually not going to use that data in this study, although I will show it to you. So that's why I haven't run those types of checks for this study too. Okay. All right. So right, our approach here empirically is going to be a little bit different than in study 1. Right, in study 1, it was quite straightforward. Right, we're essentially including a female dummy in predicting beliefs of score. Right, conditional on how you performed, is there sort of a difference between men and women? Right here, the hypothesis is slightly different. We can check for sort of that gender dummy effect, but we're more interested in sort of the behavior, like how does behavior change as we increase the extent to which a given domain is sort of more gender congruent, right? So the idea here is we expect, holding ability fixed, that women are going to grow more confident as the domain becomes more female typed, and vice versa for men. We're going to follow past work here, and we're going to model an individual's belief of their ability as being, you know, a function of their own performance, right? We're going to control for that, but also influenced by the gender gap in performance in the domain. So again, that gender gap in performance is going to be our proxy for the gender type of the category. So things that men perform better on an average are going to be more male typed, right? Things that women perform better on an average, we're going to consider more female typed. I'm going to call this own gender advantaged, right? So the hypothesis is, holding your own ability fixed, we expect that your beliefs are going to grow more optimistic as the own gender advantage in a category increases. So I just want to show you, this is what average performance for men and women in the different domains looks like. The solid black line is the average slider scale ranking, right? From more female typed to more male typed, right? And then our measure of gender type is going to be this gender gap in performance, right? So here's our 2 more female typed areas, all the way up to our more male typed areas. And you'll see that the slider scale ranking and the average gaps in performance are actually quite correlated, right? So that's why it doesn't turn out to make much of a difference whether you use the gender gaps in performance or the slider scale ranking. The other reason I wanted to show you this graph is that, you know, yes, we have a good amount of variation in gender type of category, right? We have categories that women outperform men and men outperform women in, but we also have a really good amount of variety in the sort of difficulty of the category on average, right? So there are female type categories that both men and women find quite difficult, right? Versus find easier, right? And importantly, we're also going to be able to sort of separate the difficulty of the category from the gender type of the category. So in particular, think about something like business, right? Well, business in absolute terms is quite difficult on average for men. They're answering fewer than 6 questions correctly, but they have the gender gap in performance to their advantage, right? Compare that with something like Disney movies or Kardashians, where their absolute performance is significantly better, but they're at a disadvantage in terms of gender type, right? So that's going to allow us to tease apart, right? It's not going to be the case that gender type matters just because it's something that's easier on average for your gender. We're really going to be backing that apart from sort of the difficulty component, or at least the average difficulty component. Okay, so again, in line with past literature, we find a significant role, both for gender and own gender advantage, in predicting prior beliefs of ability, right? So if we predict your belief of your absolute score from your gender, right? This takes 1 if you're a woman. So conditional on having the same score for an estimated gender neutral category, we think women are about a ½ point less confident in terms of how they think they did. And we find a significant impact of own gender advantage. So as we go from a gender neutral category to a category that has sort of a 1 point advantage on average for men, right? That's increasing men's beliefs of their own ability by about 0.17 points, while simultaneously decreasing women's beliefs of their own ability by that same 0.17 points. Okay, similar effects in terms of relative rank, although I'll skip that in the interest of time. So I do want to show you a little bit of data just on the shapes of their priors, right? So this was, I think, one of the things we were really excited about in running the study, right? We have this data. The data I just showed you is just the beliefs of the mode, right? What do you think your guess was? But we do have these full distributions. And in fact, if we sort of pull measures out of the full distributions, like the mean of your prior, we get exactly the same results. But I want to show you a little bit, some descriptives on what these priors look like. And I know Manuela is here, so I can say Manuela did a ton of work, right? She worked for like months and months to learn all these fancy statistical packages. We're going to make these beautiful figures of what these priors look like. They're going to tell us all these interesting things. And it turns out there's just not a whole lot going on in the priors. They give pretty similarly shaped and similarly diverse priors across the range of domains in a way that I think sort of surprised us. But I'll show you some of that data here. Okay, so overall, I would describe these priors as being maybe surprisingly tight, right? So the median range, the person puts only positive weight on 4 possible scores. About 20% of distributions are symmetric. The rest are evenly split between left skewed and right skewed. We do see some evidence of just a gender difference. So sort of independent of gender type of category, we see women reporting narrower, less variant priors. Right? So women seem to report tighter priors than men do. I think this is sort of interesting in thinking about past evidence that found women more conservative than men, right? If we were sort of underappreciating differences in variance in the prior, that would also maybe lead to women looking like they were more conservative relative to the Bayesian prediction. So our results seem sort of in line with that type of interpretation. Effects by gender type of the category are not super clear. As I mentioned to Alex earlier, people do put more mass on the mode of their prior in those gender congruent categories. But at the same time, they actually have slightly more variance in the gender congruent categories. So those two things seem to go in sort of opposite directions. So not a clear picture of how stereotypes are actually sort of shaping these distributions. So let me just show you a little bit of really simple evidence on what posteriors look like. So this graph is just thinking about average change in beliefs, right? So plotting the mode of your posterior minus the mode of your prior. So positive numbers are going to indicate that they're increasing their beliefs. Okay? So we see in male-typed areas, men and women are increasing their beliefs. Men directionally more so than women. In the female-type categories, we actually reverse that pattern. Right, already suggesting that sort of how we react to information is going to be a function of how gender congruent the area is. It turns out there are sort of 2 behaviors that both the Bayesian model predicts as being optimal or the right response to the information, and that show up as the 2 most common things our participants do. And they're quite intuitive. Essentially, if you see a signal and you thought there was a decent enough chance of that being a possible score of yours ex ante, you should update your beliefs to the signal, right? The signals are that informative that if you thought there was really any chance that could be your score beforehand, you see that score, you should update or report the signal as the mode of your posterior. The other behavior, right, is you see a signal that you did not think was particularly likely in your prior, right? So you dismiss it, and instead you report the mode of your prior as the mode of your posterior, right? So you either believe the signal enough to update to it, or you don't believe it enough and you just stick with what your prior belief was. those are the two main types of behavior we see. Okay. And this is just breaking down those two types of behaviors, again, by gender and gender type of category, right? So you see women more likely directionally to stick to their prior in the male-typed areas, men more likely to stick with their prior in the female-typed areas. So again, that stickiness to prior seems to be a function of gender type rather than gender. And yeah.
Sorry, can I interrupt you with a question? Because this is coming from the audience, but I think it's a really interesting thing. Did you have any assessment about people's belief in the veracity of the signal information and whether that varies by the congruence of the task? So if I'm like, do I discount if I'm like, I just don't believe your feedback? I mean, it's interesting because it could also be motivated reasoning, but like, I don't believe your feedback when it's gender incongruent than when it's gender congruent.
Yeah, so I don't have a direct measure of that, right? I don't ask them, do you think the signal was wrong? But in a sense, their beliefs are telling us that, right? If they update to the signal, they're telling us they believed it. And if they don't, well, then they probably didn't, right? So I want to distinguish between two things. I don't think there's a good picture for, differences in sort of trust of the experimenter to follow through on what the actual structure is. I think that story doesn't do a good job explaining the data because you'd have to believe that actually the experimenter is telling the truth in the female type things and not in the male type things. That probably seems a little bit less plausible. But I think the other version of that is an intuitive explanation for the results that we're going to see and that show up, right? Which is, when I see something sort of surprising, in particular, good news surprising. Hey, actually, this is a little bit better than I thought. What's the likelihood that I think, oh, it turns out I did better, like this is the truth, versus, oh, that must have been the noise straw, that can't possibly be true. And what we see is people's propensity to take one of those two explanations is exactly a function of whether that's sort of a stereotype confirming good news, hey, I'm a woman and I did better than I expected in a female type thing, versus stereotype disconfirming, right? I'm a woman and I did better than expected in a male type thing. So I think we don't have the direct data, again, on like, do you believe what I just told you? But I think that's a good way of interpreting the belief information they're giving us, right? That has to be an intuitive explanation for what's going on.
So Katie, let me just push you a little bit on the cognitive processing issues here. Because, I mean, you don't really think that they are saying, oh, this is a female type area, you told me I did good, and so I believe it. They're not actually going through that process. And so what I'm wondering is maybe they're changing the mode of their processing. So if you know this very old work of Shafir and Tversky on choosing versus rejecting, when people are looking at a set of options and they're choosing, they're thinking about the good things that they like about those options.
Interesting.
When they're rejecting, they're thinking about the negative options, things of the options. And so they actually choose and reject the same option. Now, could something be going on here in reaction to the stereotype categories? That is, a woman who is getting some news about a consistent category, gender consistent, is saying, oh yeah, I can think of all the things I know about this category. That is, they're thinking about the positive things. Versus they get news about a gender inconsistent category and they're saying, they're thinking about the things they don't know. And so that's leading to not believe it. And so that's kind of a richer story about what's happening cognitively. And so, I think your results are fascinating and believe them. I'm trying to figure out what is actually happening in terms of how people are processing this and why.
Yeah, I love that connection. I think, it's going to be hard in my data to narrow in on exactly the cognitive mechanism. And it's not that I have more data that I'm not showing you that speak to these things. But I think I love that interpretation. It's definitely worth getting into in the future to think about, can we sort of understand a little bit better about what leads to this divergent behavior across gender type of the domain, because all we can do is sort of speculate as to the type of thinking that's going on, but I'm not going to be able to say exactly. But I think this idea of sort of looking for reasons to believe versus looking for reasons to not believe is a really interesting one and could certainly be part of the story too.
And you could think about turning it off by prompting them to think one way or the other and see if you can shut down this mechanism.
Yeah, that's great. Great. Okay. So let me show you a little bit more formal analysis of these posteriors, right? So similar to what we found in study 1, right? If we think about sort of, do the signals reduce reliance on stereotypes, right? That coefficient on own gender advantage, right? In priors, we estimated that a 1-point increase in own gender advantage increased your beliefs by about 0.17 points. In posteriors, it's 0.14 points, right? So again, not a significant reduction, get a directional reduction, but not a large one. No spillovers onto beliefs of relative ability. Skip past this in the interest of time, right? So I think here the really valuable part of the study too, in some ways, is that we do have this information on full distributions, so we can think about actually how much of this behavior is consistent with the Bayesian model, right? Again, like I mentioned before, there's a Bayesian channel for this type of behavior, right? Men and women start with different priors in a male type domain. Even after seeing the same information, the Bayesian model is going to predict that they end up with different posteriors potentially. Right? Of course, there's also a non-Bayesian channel, which is even starting with sort of similar priors and seeing the same signal, they update in different ways, right? Even though the Bayesian model would predict them ending up with the same posterior belief, the beliefs actually diverge. Okay, so the way of getting at this is we're actually going to use the full distributions and the signal they received to make a Bayesian predicted posterior for each participant, right? And we're going to do this in terms of mode. You could also do it in terms of mean and get similar results, right? So here's our specification from before, predicting their posterior. Again, the key coefficient is thinking about this impact of own gender advantage. Now all we're going to do is add to the model the Bayesian prediction for this posterior, right? What does the Bayesian model think their posterior should be? If all of this impact of own gender advantage is actually Bayesian, we should expect that this would pick up a lot of weight and this coefficient would go close to 0, right? Dramatically reduced. And what we see is that the Bayesian prediction does reduce some of the explanatory power of own gender advantage, but far from all of it, right? There's still a large and significant coefficient on own gender advantage, even conditional on the Bayesian prediction for each participant. I want to show you a little bit of visual evidence on this. You can see this across a lot of the data in the experiment, but it's one thing that I think is worth emphasizing that's quite striking. So here at the x-axis is what the Bayesian model predicts would be your posterior, and the y-axis is what you predict as the mode, or what you report as the mode of your posterior, right? So a 45-degree line would be people behaving exactly in line with the Bayesian predictions on average, right? Again, these are linear fits, right? So the solid line here is men in male-typed categories, whereas the dashed line is the men in female-type categories. So what you'll notice is that people are behaving slightly more in line with the Bayesian model in the male-type categories for men. When we add women, right, similar finding. Again, the solid line is the women in female-type categories versus the dashed line is the women in male-type categories. Right, so a big focus of past work has been predicting the extent to which someone behaves in a Bayesian fashion, right? And showing that actually I think women behave in a less Bayesian fashion than men on average. Here, what we really see is that's going to be a function of the gender type of the category. People are behaving in a more Bayesian fashion in the more gender congruent ways. And in fact, if we compare men and women in gender congruent categories, their behavior is almost identical on average. All right, so I only have a few minutes left, but I want to talk a little bit about good news and bad news, right? And I think this really pulls the results all together, right? Thinking about, are there differences in how participants respond to good news versus bad news, right? So I'm going to think about good news as being a signal that's greater than or equal to your true score, and bad news as being a signal less than your true score. Right, so this is going to be using the exogenous noise draw. You could also define it relative to their prior rather than relative to the truth. You would get the same types of results. Okay, so we're going to follow the approach of Isle and Rao. We're basically predicting your belief from the Bayesian prediction, including a dummy for whether it was good news or bad, and then interacting that good news term with the Bayesian prediction. So in particular, this interaction of good news with the Bayesian prediction is asking, are you behaving more in line with the Bayesian model, right? Are you updating more consistently with Bayes when it's good news as opposed to when it's bad news? Okay, so in the interest of time, I'm just going to skip to sort of an organizing slide of these results. Again, this is sort of mapping the responsiveness, right? So this is sort of, think of this as a measure of how Bayesian you are, right? Depending upon whether you saw good news or bad news, whether it arrived in a gender congruent or a gender incongruent area, and then the data for men and women within each cell. Okay, so I'm gonna try not to go too fast without getting cut off. Okay, so here are a few takeaways. men and women similarly responsive to good news when it arrives in a gender congruent domain. Same thing, if we thought about sort of the other form of stereotype confirming news, so you get bad news in an incongruent domain, men and women are also sort of similarly Bayesian there, right? And in particular, these four numbers are actually quite similar, right? Responsiveness of between 0.75 and 0.8, men and women seeing that sort of stereotype confirming news. Okay, so where do the differences really pop out? I think this is by far the most striking pattern in the data, right? If we think about responsiveness to good news, right? How much do you sort of update in comparison to what Bayes predicts after seeing good news? For both men and women, they're gonna update much more in response to seeing good news in a gender congruent area than seeing that same news in a gender incongruent area. And that's really driving sort of those differences in how Bayesian they are by the gender type of the category. Okay, I know I'm out of time, so I'm gonna skip to the end of my deck and just wrap up. Oh, wow, I just did something I didn't know I could do. Did I do something funny? Okay, perfect. Okay, great, so wrapping up, what do we do in this project, right? We explore the effectiveness of feedback in closing gender gaps in beliefs of vulnerabilities, right? And I wanna go back to sort of that motivating example we started with, right? If you think about sort of that woman who might be underconfident in her talents in STEM, right? Is it gonna be effective for us to just sort of provide her more information with how good she is, right? And our results suggest that actually this is exactly the cell where information is least effective, right? When you sort of give someone good news in those gender incongruent areas, suggesting that maybe other policy interventions, other sort of options might be more effective. All right, great, I will stop there. Thank you all so much. I know I'm out of time, so I probably don't even have time to take any more questions, but I will stop sharing my slide so we can come back together.
Thanks so much, Katie. That was really great. And thanks to all the panelists for joining. Thanks to all the audience members for coming today. All of your questions will be logged and shared with Katie, even if she didn't get a chance to answer them. So don't worry, your voice is being heard by her anyway. So thanks, everybody. We'll see you next week.
Thank you all.